It's funny how often we just completely write something off.
Oh, yeah, absolutely.
Like a hobby or a topic or even just a specific plant. We try it once, it doesn't work out, and we just say, well, that's boring.
Right, or that it's just too difficult.
Yeah, exactly. Until you find that one specific variation that just completely changes your mind. And that is exactly what we're getting into today for this deep dive.
It is a really fascinating case study.
It really is. So we are looking at a specific piece of source material today from a blog called qianmeng.org. And I was looking at the metadata for this post, and the sheer volume of this guy's output is staggering.
Yeah, it's not just a casual diary entry we're looking at here.
No, it's literally titled Notes on Gardening Part 810.
Which is a massive data set. Most people start a gardening journal. They get to maybe week 3, they forget to water the tomatoes, and the journal just dies with the plants.
Right.
So this is entry 810.
And the author, Ang, he describes himself as an old software plumber. He dabbles a lot in free and open source software flawfulness.
Yeah, and that context is everything for this deep dive.
Because when you read this post about his experience with a specific flower, the Globe Amaranth, you realize pretty quickly that he isn't just gardening.
No, he's administering a system. He's managing a biological server farm, basically.
Exactly. He tags his posts with things like open source and Haskell, Python, and fish keeping.
So when he approaches a plant, he's not looking for poetry. He's looking for performance metrics and uptime and bugs.
And the mission for us today is to unpack his experience with one very specific patch he installed in his garden, a cultivar called Fireworks.
The Globe Amaranth Fireworks.
Right. But before we get to the successful deployment, we kind of have to talk about the legacy code, because his relationship with this plant did not start well at all.
No, it really didn't. He had essentially written off the entire species. The Gomphrena globosa was basically bloatware to him, just useless.
Which is funny because the Globe Amaranth is a staple in so many places. It's that little round, kind of clover-looking flower you see in supermarket bouquets.
Or gas station planters. It's everywhere.
It's everywhere, and I think that's usually the problem, right? Familiarity breeds contempt.
Yeah, and Ang mentions that he had actually tried to grow them from seeds years ago during what he calls a previous gardening period.
And the data he got back was just terrible.
He literally calls it lackluster. He sowed a high volume of seeds.
Basically spamming the soil.
Right, spamming the soil.
Yeah.
And he only got 1 or 2 to germinate.
Which, from an engineering standpoint, that is a terrible conversion rate.
Oh, yeah. If you write 1,000 lines of code and only 2 of them compile, you scrap the project. You move on.
And even when he saw them out in the wild at nurseries or garden centers, he says they failed to entice him.
Which I think is a very polite way of saying they looked completely boring.
Yeah, he specifically calls out the typical mundane dwarf varieties.
Those are the really compact, genetically squashed versions that are bred specifically for pots. They're very predictable, very small, and frankly just uninspiring if you're looking for something dynamic in a garden.
So the ticket was closed. The species was ignored until he saw the upgrade.
The Fireworks cultivar.
I love how he describes this discovery, too, because it wasn't some romantic moment in a sunlit meadow.
No, he was just shopping during the festive season.
Right, shopping during the festive season. He sees this new version, and he notices the specs are completely different.
It's a total redesign of the architecture. The Fireworks cultivar isn't that tight little ball he was used to. It's taller, the blooms are much larger, and most importantly, the structure is open.
It creates a completely different visual profile.
Exactly.
And because he is a software plumber, he didn't just buy them because they looked pretty. He bought 2 specimens for evaluation.
I love that phrasing so much. For evaluation.
He's beta testing them.
He really is. He wants to see if this new version runs stable in his specific environment, which is a tropical climate, by the way.
So let's actually get into the evaluation part. He gets these 2 units home, and the very first thing he notices is the build quality. And honestly, it sounds a little flimsy.
It does. He notes pretty early on that these stems are quite brittle and snap easily.
Which seems like a major design flaw for a plant that grows tall, right? Like if you're going to be big and showy, you should probably be sturdy.
Well, this is where we get into the trade-offs of being an herbaceous perennial.
Which essentially means it's running on a totally different engine than a tree or a shrub.
Exactly. Herbaceous means the plant doesn't produce persistent woody tissue above ground.
Right.
It's all soft, green, water-filled cellular structures. And the advantage there is speed. You can deploy biomass very, very quickly because you aren't spending energy building complex lignin structures.
You're not building wood to hold yourself up.
Right. So it's agile development.
Move fast, break things.
Literally break things. Because it prioritizes rapid growth and flowering over structural armor, it is inherently fragile.
Eng notes that you have to handle it with extreme care, or the stems just snap right off.
It's a glass cannon strategy in evolutionary terms.
Yeah.
You have high output, but very low defense.
But the fragility isn't the only thing he noticed.
Yeah.
And this is where the deep dive gets really, really cool for me. Because he started looking at the flowers themselves, the actual fireworks.
And he realized that what he was looking at wasn't a flower at all.
This is the bract versus flower distinction, and it is something so many people just completely miss.
Eng points out that the bright purple-pink explosion that catches your eye from across the nursery.
Those are bracts.
Correct. They're essentially specialized leaves that have evolved to look like petals.
Right.
They change color and shape to create a landing pad or a signal beacon for pollinators.
It's basically front end versus back end, isn't it?
Well, that is a perfect analogy.
The bracts are the UI. They're the flashy user interface designed to get the user or the pollinator to click.
The bract is the UI. And the actual flower, the back end where the database transactions actually happen, are these tiny, bright yellow pins tucked inside the bracts.
Eng describes them as poking out from the rounded heads.
Right.
And he mentions the texture, too. He says the bracts feel fragile and papery to the touch, even when they're fresh.
And that texture is a dead giveaway that you aren't touching a true petal. Petals are usually full of moisture, they're very delicate, and they wilt very quickly once the pollination job is done.
But bracts?
Bracts, because they are modified leaves, have a completely different cellular structure. They're drier, they're tougher, and they last much, much longer.
Which completely explains why Globe Amaranth is so popular for dried flower arrangements. The quote-unquote flower is already half dried even when it's alive.
Exactly. It's incredibly efficient coating by the plant. Why build a delicate, high-maintenance petal that fades in 3 days when you can just modify a leaf to stay purple for 3 weeks?
The plant is just maximizing its uptime. So Eng has identified the hardware limitations, the brittle stems. And he's figured out the software architecture. The bracts acting as a front end for the tiny yellow flowers.
But now he actually has to keep the system running.
And this is where the life cycle management comes into play. He notes that in his tropical climate, these are tender perennials.
Which implies they can last a long time, but they aren't immortal.
Right. He estimates a lifespan of over 2 years. But, and this is a really big, but there is a degradation in performance over time.
The dreaded woodiness.
Yes. He observes that after about 18 to 24 months, the stems, which are supposed to be herbaceous and soft, start to get woody.
Wait, I thought we just established that herbaceous perennials don't make wood.
Well, they don't make true wood like an oak tree. But as the plant ages, the cell walls thicken, they accumulate lignin. It's a process called lignification.
Okay.
The plant is basically trying to support its own weight as it gets older and messier.
So it's technically becoming more stable.
Structurally, maybe? But functionally, it is a disaster. Eng notes that this woodiness leads directly to a decline in flower production.
Ah, it's legacy code bloat. The system just becomes too rigid.
Exactly. It can't pump water and nutrients as efficiently as the fresh green stems could.
The vascular system gets constricted.
Yeah.
So you end up with this old, woody, gnarly plant that is technically alive, but it's no longer doing the one thing it was designed to do.
Produce flowers.
Right.
So Eng is watching his 2 evaluation units. They are running well right now, but he knows this crash is coming. The 24-month wall is rapidly approaching. He needs a backup strategy.
And this is where he pivots his approach to propagation. He needs to fork the repository before the main server goes down.
He mentions that he's already experimenting with cuttings.
Which is a very smart move.
Oh.
Remember, his previous experience with seeds was a total failure.
Right. The lackluster germination.
Cuttings are a way to completely bypass the uncertainty of germination.
It's discloning. You take a piece of the running system, you stick it in new soil, and it just keeps running.
And genetically, it is identical. That's the key point here. When you grow from seed, there's genetic variation. You might get a plant that isn't quite like the parent.
But with a cutting, you are cloning the fireworks cultivar exactly.
You keep all the features you like. The open blooms the specific color.
And he says the cuttings appear to be effective so far, so he has basically solved the persistence problem. But then, and this is the part that proves he's a true tinkerer, he says he isn't satisfied with just the cuttings.
No. He writes that he looks forward to seeing if he can harvest seeds from this specific cultivar.
Which raises the question why? If the cuttings work and the seeds failed him so badly before, why go back to the method that gave him such a lackluster return?
I think it's pure curiosity, the need to completely close the loop. He wants to know if the failure years ago was user error or bad data, meaning bad seeds, or if it was just the mundane variety he was using.
And now that he has a thriving fireworks colony, he has an unlimited supply of fresh seeds to test with.
He wants to rerun the test with better inputs.
Exactly. He wants to debug the germination process because maybe fireworks seeds are just more viable than the generic ones. Or maybe his soil mix is better now.
He can't call the evaluation complete until he has mastered both cloning and sexual reproduction of the plant.
It's really all about control, isn't it? If you rely solely on cuttings, you are limited by the physical material you have on hand. But if you can crack the code on seeds, you can scale infinitely.
And you can share them. You can store them for years. Seeds are basically the ultimate compressed file format. If you can get them to work, he has truly mastered the system.
You know, stepping back from the botany for a second, what really strikes me about Ang's notes is just how he treats the garden as a series of logic puzzles.
It's very distinct from the traditional romantic gardener archetype.
Right. He isn't talking about how the flowers make him feel. He doesn't say they bring me joy. He says they were purchased for evaluation.
He talks about stem brittleness as a structural property.
But I would argue that is exactly how he derives his joy. The joy isn't in just passive observation, it's in the understanding.
When he figures out that the petals are actually bracts, that is a massive dopamine hit for him. That's his aha moment.
That's a really good point. It's the engineer's high. Understanding how the machine works is infinitely more satisfying than just watching it spin.
And notice the patience involved, too. He is tracking a 24-month life cycle. He is referencing experiments from years ago. He's building a huge knowledge base, entry by entry.
Entry 810 builds on the failures of entry 200.
Exactly.
It kind of makes me wonder about our own metaphorical gardens. We all have things we try once we fail at it, and we say, oh, I'm just not good at that. Or we say that topic is just boring.
Just like he did with the dwarf Globe Amaranth.
Exactly. He thought the whole species was trash because he ran one bad version of it. It took the fireworks update to make him realize the potential was actually there all along.
It really forces you to ask yourself, are you using the mundane dwarf variety of a skill or a hobby? Have you completely written off an entire field of study just because the introductory class was a bit dry?
That is the ultimate takeaway right there. Sometimes you just need to find the fireworks cultivar to really understand what a thing is supposed to be.
And you need to look closer at the structure. Don't be fooled by the bracts.
Let's actually circle back to that bracts versus flowers thing one last time, because I think it's the strongest metaphor here. We move through the world looking at the big flashy purple leaves and thinking, oh wow, that's the flower.
We constantly mistake the advertisement for the actual product.
Right. We focus on the UI, the thing that's designed purely to grab attention, and we completely miss the tiny yellow pins where the actual work is getting done.
In a company that might be confusing the marketing department with the engineering team, or in a big project focusing entirely on the slide deck instead of the underlying data analysis.
But bracts are important, sure.
They get the pollinators in the door.
But if the tiny yellow flowers aren't working, there are no seeds, there is no future generation.
And Ang only figured that out because he actually touched it. He felt the papery texture, he got in close.
He didn't just scroll past, he actively engaged with the material.
So as we wrap up this deep dive into qianmeng.org's 810th gardening note, I think the mission for you listening is pretty clear. You need to channel your inner old software plumber.
Evaluate your systems.
Don't just water your plants. Debug them. If something isn't working, like those woody stems, ask yourself why. Is it legacy code? Is it time to refactor and maybe take a cutting?
And don't be afraid to rerun an experiment that failed years ago. The conditions might have changed. You might have found a better variety.
Ang went from fail to entice to full-on propagation experiments just by changing the input variable.
And by being willing to look at the data again.
So here is a final provocative thought for you to chew on. We talked about how the bracts are an illusion, a modified leaf masquerading as a flower just to get attention.
A highly functional illusion.
Sure, a functional one. But think about your own field, whether you are a coder, a writer, a teacher, or a manager. What is the bract that everyone focuses on?
What is the flashy, papery thing that takes up all the space?
And conversely, what is the tiny yellow pin? The microscopic, boring-looking part that is actually doing the critical work.
Identify the pin. Try to ignore the purple leaves for just a second. That is where the seeds really are.
And that is where the growth actually happens.
Thanks for diving in with us today. Keep debugging.
See you in the garden.